Hi, my name's Roger Ward. I'm going to talk to you about natural language processing today. I've been inspired by this study that's going on in the States looking at COVID. A large number of centres are using the same natural language processing pipeline, and it utilises the Odyssey OMOP Common Data Model, which is what interested me. So I've downloaded and had a look at the natural language processing. It's called CLAMP. And here's an example. I've got it running on a Windows virtual server. And these are the pipelines. And I've just put in some example text here. So this is something that I've just made up. I've just typed this in, put in some fictitious patient details and some diseases. And now we'll run the NLP on that data. Now it takes a few seconds to run. The interesting thing about CLAMP is it integrates the BRAT tool, which many of you who've used natural language processing will be familiar with. And I'll show you that in a second. So this is just a status window saying that NLP is still running. This is happening in real time, so let's have a look at the output now. So these are the two output files. And the first one is an annotated file using BRAT. And it highlights the conditions or the problems: asthma, cough, shortness of breath, history, COPD, CKD, depression, anxiety. So it's done a pretty good job of identifying those. And this is the other output. It strips out the text and puts just the conditions and drugs in a text file. Okay, now we'll go to look at another aspect of natural language processing, and this is de-identification. So I've just, again, done a very simple file, done a very simple example file here, run natural language processing on it, and we'll see how it performs. So we'll have a look at the output. And here it is. So identified Richard Smith, Jones, Alfred Hospital. Made a little mistake there. It thinks Richard Smith is the doctor in the first sentence. Again, there's a text file produced with the stripped out data. Now the important thing to do, note here, is it's identified all the PII, personally identifiable material there, and stripped it out. So this is the stripped out version of the text file. So it's done a pretty good job of de-identifying that really simple test file. Okay, now what I've demonstrated so far are really simple text files that I've just typed up. What we've got here are some more complex example medical notes. And as you can see here, these are typical of what you might see in an EMR. Some sample notes. So now we'll run the pipeline, the clinical pipeline on these notes. Now I've shortened the video at this point. It actually takes just under 2 minutes to run all those notes. But for the purposes of the video, I've just shortened it so we can have a look at what's been found. So we've still got the progress window running, and here we go, it's finished. So let's have a look at some of the output. So it's identified problems. It's done a pretty good job. It gives you some context of what's happening in the notes as well. And if we look at the sample text file, it's given you all the conditions and the medications and the diagnosis. So it's done a pretty good job. So this is the annotated BRAT file again, on another set of notes. And as you can see, it's done a pretty good job of identifying all the conditions and the context of what's happening, and the drugs. It's identified chemotherapy there. Okay, so that's a very simple first look at natural language processing with CLAMP. It looks very promising, but obviously the next steps are to systematically examine precision and recall, and that's something I'll be doing over the coming weeks. Thanks for watching, and I hope this has been useful.